Hi, I got something a little different today. I had a request from a viewer DHY to derive some of the hyperbolic trig functions and identities. I'm not going to give too much background. It's mostly going to be just the derivations to see where all these formulas and identities come from. So we have on the right our definition of hyperbolic sine or sinh, and similar definition for hyperbolic cosine or cosh of x. And before I get into any identities, what I'm going to do is just let's look into where this came from. Okay, so what we'll do is use Euler's formula, which is just this top formula we have here on the board. This defines e to the ix in terms of sines and cosines. And then the second formula is all we do is if you plug in the input negative x into here, with a little simplification, but sines odd and cosines even, you get cosine x minus I sine x. And then what I'm going to do with these two equations is we'll just add these two together, and we'll see that when we add them, we'll see our sine terms cancel, and we'll have e to the ix plus e to the minus ix equals 2 cosine x. But then we can just divide a 2 on both sides, and we get our identity for cosine x, this is our complex definition of cosine x, which is e to the minus ix, which is e to the ix plus e to the minus ix over 2. And then we can do something very similar. We can just subtract these equations instead of adding them. If we subtract them, the cosines are going to cancel. We're going to get, on the left side, e to the ix minus e to the minus ix equals, and then subtracting these, we're going to have 2I sine x. But then we'll divide a 2I on both sides, and we're going to have our complex definition of sine x. So from here, what we're going to do, we're going to take our definition of cosine, and instead of using x, we're going to plug in here cosine of ix. And then we'll just, wherever we see an x, we're going to plug in the ix. So we're going to have, this is going to look like e to the I times ix plus e to the minus ix over 2. Then I to the I is just minus 1, so we're going to have e to the minus x plus, and then here we'll have a minus 1 times a minus, so it's going to be e to the positive x over 2. But what you'll notice is what we have here, we just get back, this is actually the same thing as cosh of x. So this is pretty nice that we know that cosh x is actually the same thing as cosine of ix. Then we're going to do basically the same thing with sine x. We're going to look at sine to the ix and plug in. Just plugging in using this complex definition of sine, we plugged in an I for wherever we're seeing x over here. And then again, I times I is minus 1, so we're going to have e to the minus x minus e to the plus x, but then we have this 2I over here on the bottom. And so this isn't quite our definition of sinh. Okay, but we can make it that way if what we can do is we can multiply here by minus I and multiply here by minus I. And then doing that, this I is going to cancel here with this, and this is going to reverse the sign up top here. So we're going to end up with e to the x minus e to the negative x over 2. And that's our definition of hyperbolic sinh, or sinh. And then from here real quick, we can look at what happens if we look at cosh ix. If we know that cosh of x is cosine ix, it's going to be cosine I squared of x. So that's cosine minus x, which is just cosine x. And then we'll do the same thing for sinh. So if we look at sinh of ix, this is going to be the same thing as minus I, using this, sine I squared x. So then we're going to have a minus I sine negative x, but we can bring the minus out, and so this is going to be I sine of x. So actually when we add cosh of ix plus sinh of ix, then we're actually just adding cosine of x plus I sine of x. But what's that? That's Euler's formula again, so this is actually e to the ix. So we end up, by doing this, we end up with this cool identity and a way to have Euler's formula in hyperbolic functions. Okay, and so now that we've established all that, I think we can look at some identities. So first let's look at what happens when we add cosh x and sinh x together. What I'll do is we'll write cosh x, but I'm going to separate it out. So instead of writing it all, we'll write it as ex over 2 plus e minus x over 2. And then adding sinh, we're going to have ex over 2 minus e minus x over 2. But these terms cancel. We have two of these and they're a half each. So this is actually e to the x. Then next we'll do something really similar. We're just going to subtract these, kind of the same thing. Okay, now what happens when we subtract these two terms? Well, now it's just a different cancellation. These terms are going to cancel, but then we distribute the minus in here, and now we're adding the e to the minus x terms, and we're just going to have the difference of these is going to be e to the minus x. And what that's going to do is this is going to help us with our identity with what happens when we have cosh squared x minus sinh squared x. So then writing this as the difference of two squares, we can use what we just found. We know that this value here, the sum is going to be e to the x, and then we know the difference is going to be e to the minus x. But multiplying those together, e to the x times e to the minus x is just 1. So we have this identity, that cosh squared minus sinh squared is 1. I just took our definition of cosh and put it up here. And what we can do is let's just square both sides and see what happens. But what I'm going to do, okay, so we're looking at cosh squared x. Let's take our half out front. So we'll square these separately. It's just a little easier for me that way. So we'll square half squared, and then we're going to have e plus e to the minus x squared. Okay, this term's going to be 1/4. Then here we'll just kind of do our distribution. So we're going to have e to the 2x plus e to the minus 2x plus 2. Next, I'm going to take my definition of sinh x right here that we got, and we'll do the exact same thing. We're just going to square both sides. Okay, and squaring that, you notice we get like almost the same thing, but we just have a minus 2 here instead of a plus 2. Sorry, I don't know how long I had this here, but when I copied this down, I had a plus sign there, so I changed that to a minus. Okay, so next what we're going to do, we're going to take these, we're going to take our definition, we're going to find cosh squared x minus sinh squared x. So we're just going to subtract these two, so we're going to end up with 1/4. Now when we subtract an e2x from e2x, we're going to have a 0 there. The same thing with e minus 2x. If we subtract it, that's going to cancel. Then we're going to have 2 minus minus 2, and that's going to be a 4. 4 times a 4th is 1. So that's how we get this one right here. This is another way to do it. Let's find what happens when we add cosh squared x and sinh squared x. So when we add these two equations, we'll keep the 1, we'll factor out a 1/4. We'll add e2x and e2x, and we'll have 2e2x. We'll add minus 2x and e minus 2x, and we'll have a 2e minus 2x. And then 2 minus 2 is 0. Then let's just distribute our 1/4 in here, and we're going to have e to the 2x plus e minus 2x all over 2. But that's actually the same thing as cosh of 2x. Okay, now just the last derivation I want to do is the double angle formula for sinh. We're just going to take 2 sinh x cosh x and see what happens. This is really exactly the way it works with regular sine and cosine, right? Because 2 sine x cos x is sine 2x. Okay, so let's look at this. So we'll do 2. I'm going to write sinh with the half out front, so we'll write it as half e to the x minus e to the minus x. And then the same thing with cosh, we'll write a half out front, e to the x plus e minus x. Then what I'll do is, let's see, I'll cancel a 2 with a half here to get a 1. We'll have a half out front, and then we'll just distribute these to get, we'll multiply these together. So we're going to have e to the 2x, e to the x times minus e to the minus x, that's going to be a minus 1. And then e to the x times positive e to the minus x is going to be a plus 1. And then these last terms, we're going to have minus e to the minus 2x. And we'll just rewrite this so we can recognize that we're going to have the e2x minus e to the minus 2x over 2. But that's what we wanted to show. That's our sinh of 2x. That's it. A brief intro to the hyperbolic trig functions. Hope that helped. Thank you for watching. Please like and subscribe. Have a good day.